In the previous video, we started thinking about ionic compounds, and we began introducing some of the ideas that are going to become important in thinking about the chemistry they undergo in solution. Okay? In this video, we're going to expand these ideas to thinking about solubility of ionic compounds. So solubility meaning how much will they dissolve in water, or how readily will ionic compounds dissolve in water. So solubility is will they dissolve. So just as a really quick recap, we discussed how sodium chloride can dissolve in water because water can surround sodium and surround the chloride anion and prevent them from interacting. Okay, so the way this happens is there are forces that are interacting. There are forces that allow the chloride anion to interact with water molecules, and there are forces that allow the sodium cation to interact with the water molecule. And these forces are preventing the sodium from directly interacting with the chloride, which, if they were allowed to react, they would come together and make a sodium chloride solid. But the presence of water prevents this reaction from happening. Okay? But as it turns out, not all ionic compounds make a really strong interaction between the cation in water or the anion in water. Sometimes, in the presence of water, the solid form of the ionic compound is more stable. So in this video, we're going to explore the rules that allow us to predict which ionic compounds will be soluble, meaning they do dissolve in water, and which will be insoluble, meaning they'll form the solid when they're present in water. Okay? These rules are pretty straightforward. All right, so soluble compounds. If your ionic compounds contains the cation ammonium or a group 1A metal, so this would be like sodium or potassium or really any other cation that's found in the first column of the periodic table. If it contains either of these cations, then it will be soluble. In addition, if an ionic compound contains some standard anions, they'll also be soluble. So an example of this might be if your ionic compound contains nitrate, acetate, which we know is CH3CO2-, or you might also see this written C2H3O2-. These are both ways of writing acetate. Or perchlorate, which is ClO4-1. Okay, so if the ionic compound you're looking at contains any of these ions, ammonium, an alkali metal, nitrate, acetate, or perchlorate, then it is soluble. In a similar way, we can write out some common ions that are most likely found as insoluble compounds. So insoluble. Okay, so things that are normally insoluble. Lead cations, the mercury cation, and this is a little bit weird because it's two mercuries together, so Hg with the subscript 2 and overall has a charge of 2+. Silver is usually insoluble. Anions, we have carbonate, that's almost always insoluble. Phosphate, almost always insoluble. Sulfide, and this compound called chromate. So if you see any of these cations or anions, the compound is almost definitely insoluble unless they're partnered with one of our soluble ions. Okay? So our soluble ions trump our insoluble ones in these two groups. Okay, and things that are usually soluble. So I'll put this as white. So we'll say usually soluble. So anions chloride, bromide, and iodide are usually soluble unless they're partnered with one of the insoluble cations. Okay, so let's just reinforce these ideas. If something has ammonium, an alkali metal, nitrate, acetate, or perchlorate, it is soluble in water. It will dissolve in water. If an ionic compound contains lead, mercury, silver, carbonate, phosphate, sulfide, or chromate, it's most likely insoluble unless it's partnered up with one of our soluble ions. Okay, and then our halides, chloride, bromide, and iodide, are normally soluble, but if they're partnered up with lead, mercury, or silver, they will be insoluble, right? So we have a priority list here. Okay, the soluble gets the first priority, the insoluble gets the second priority, and the usually soluble gets the third priority. Let's see a couple examples of this. Okay, so if we have an ionic compound that is ammonium nitrate, okay, so as we talked about before, we can think about this as an ammonium cation and a nitrate anion. Right? So if this compound were to dissolve in water, it has the potential to separate into an ammonium cation and a nitrate anion. And since both ammonium and nitrate are found in our soluble list, right? Here's ammonium, here's nitrate. These are both found in our soluble list, so this compound is definitely going to be soluble. It will dissolve in water. Okay? Let's explore lead nitrate. Okay, so lead nitrate might break apart into a lead cation and two nitrate anions. Okay, lead is in our insoluble list. However, nitrate is present in our always soluble list. So lead nitrate will dissolve in water. Okay, let's compare this with lead chloride. All right, so lead, we've established already, is present in our insoluble list, and we have two chlorides here. So the chlorides are usually soluble, but if it's partnered with lead, then that means it's going to be insoluble. So this compound is insoluble, meaning that it will not dissolve in water. In the next video, we'll explore how we can use these ideas to predict the phase of reactants and products in a chemical reaction that involves ionic compounds.